Hey everyone, and welcome back. So we are almost done with our similarity unit. We have 2 lessons left. We have this one and the next one, and we're going to be finishing up with a unit test then by the end of the week. So not much left to go. We've done dilations. We've looked at how to prove triangles are similar. We've done triangle proportionality theorem. There's been some constructions in there. There's a lot of stuff in this unit. Make sure you're revising over that, particularly since we've been stretching it out over a longer period of time. But you should be able to keep up with this pretty well, and let me know if you have questions as we go. All right, for today, we're going to divide a segment into an equal number of pieces. This is using a construction. We're going to be looking at this idea of ratios, what it means, and then how we use it in similarity. And then finally, we're going to be finding a coordinate that's going to divide up a line segment by a given ratio or a given fraction. So this is kind of what it's all going to culminate in, doing it on a coordinate plane. We'll do the construction, we'll figure out what ratios are, and then we'll kind of combine the two and put it on a coordinate plane question. Essential questions for today: what are the steps if you're going to do the construction? And then how do I find a coordinate that divides a segment by a given ratio? So that's kind of the big key idea for today. All right, so for the construction, I have posted a YouTube video in our Schoology page, or if you're not watching through Schoology, feel free to copy the link over. This one is not made by me, it's made by somebody else, but they did a good job on describing the construction. One thing I will say is look at it and see how could I do the parallel lines in the construction using an alternate method that we have covered in class before. So maybe like the set square method or using a protractor and so on. So just kind of think about that in your head. How could I improve this method, make it faster for myself? Let's go through the steps. So we've got a segment and we want to divide it into 5 equal parts. So that would mean that we would want to cut it 4 times. So if you have a segment, 5 equal parts, you want to put, that's a terrible attempt at 5 parts. So we want to put 5 parts into this. So 1, 2, 3, 4. So we get 1, 2, 3, 4, 5 parts. And let's assume that the endpoint was actually there. So 4 cuts, 5 parts. So we want to try and figure that one out. So what you're going to do, you're going to draw a ray. So a ray extends forever in one direction, has a definite starting point. Starting point is in the same position as one of the endpoints of the segment. It doesn't matter which one you do as long as it's one of them. You're then going to take your compass. The setting on your compass doesn't really matter. You just don't want it to be so big that, if you were to make your compass setting like 1, 2, 3, you would be going forever to finish off your 5 markings. So you want it small enough that it's going to fit on your page, big enough that it's not super cramped and you're struggling to get the compass to actually do what you want it to do. So it's kind of like a nice marking. On that 5th marking, that last one, so it's this one out here, you're going to connect that to the endpoint of the segment. So just ruler out, connecting end to end. And then this is going to be a line that you're going to try and draw parallel lines to. So every line we draw in this next step is going to be parallel to this one. So you use a parallel line construction, draw on your parallel lines. So all of these are parallel to one another. And then you can see we mark the points of intersection. This now divides up the line segment into 5 congruent pieces. So really handy construction if the line segment is too big to measure with a ruler, too small to measure with a ruler. It doesn't line up nicely with any kind of whole numbers, or it doesn't divide nicely. So it's one of those ones where the math doesn't necessarily matter. This will get you what you're looking for every single time as long as you're accurate in your construction. So make sure you've practiced that construction on your own. Try it a couple of different times with different line segments, different number of pieces, and don't just kind of look at it once and be like, I'm done. Actually practice it. Moving into ratios. Divide a segment in the ratio of 3.5. So 3:5. What does that mean? It means 3 is to 5. So that's how you would say that. So divide a segment in the ratio of 3 is to 5. What does that mean? it means that you are going to divide something up where 3 parts go to one allocation, 5 parts go to another. So if you imagine like you had a bag of M&Ms, so say and you pour them all out on the table. And you said, I'm going to divide these up with a sibling, a friend, whatever, in a ratio of 3:5. So that would mean this person gets 5, this person gets 3. And then you'd repeat the process. So another 3 for this person, another 5 for this person. So what you start realizing is that the bag is getting divided proportionally in a ratio of 3:5. In a fraction, that would mean there's 8 total parts. One person is getting 3/8 of the total, the other is getting 5/8 of the total. So what that's going to mean for us is if we're dividing up a line segment in a ratio of 3:5, we would divide it into 8 total parts. 1, 2, 3, 4, 5, 6, 7, 8. And then a ratio of 3:8 means we want 3 mini segments on one side, 5 mini segments on the other. So I would go 1, 2, 3. This would be my dividing point. So it would be 3/8 of the line on one side of it, 5/8 of the line on the other side. That's what we're going to be looking for, is this key point. So if we're going to do this with a construction, so same construction from that first slide, but we've got a particular number we're looking for. Ratio of 3:1. Now notice that there's a direction from A to B. So that means the first number, so 3 parts, is going to belong closer to A, 1 part closer to B. So when you think about dividing up this segment, you'll have A, you'll have B. The point is going to be much closer to B because you're going to have 3 parts of the line on one side but 1 part on the other. In terms of a fraction, that's 3/4 versus 1/4. So how are we going to do this? We're going to divide it into 4 equal pieces because we said we want fourths. And then put all those points of intersection. So why 4 pieces? Because there was 3 parts and 1 part, total 4 parts. So if we divide it up into 4 equal pieces, that's going to help us out here. And then we have to pick the point that actually divides the segment the way we want to. So this one here gives us 1, 2, 3 parts, like 3 congruent parts on one side of the point and 1 congruent part on the other. So that would be a ratio of 3:1 from A to B. So again, just make sure that direction looks good. Put on a coordinate plane. Not much changes. I mean, you can do this with a construction. You just have to make sure that you are being 100% accurate because we're looking for a coordinate answer. But what's going to really happen here is we are going to try and use like a similar triangle idea here to divide up this segment. So remember, if we have similar triangles, if I do something like dilate the bottom by, so what are we doing here? 3 and 3:1, so 3/4, so 4 pieces. So I do 3/4 of the original length, and I do 3/4 of original height. So that would be about here. So that would mean this triangle and the one on the outside would both have a right angle, and 2 of the sides are proportional. So like say this would be 3/4 y, this would be y, this would be 3/4 x, and the larger side would be x. So that would mean by side angle side, those triangles must be similar. Also means that the hypotenuse will be dilated as well. So this would be 3/4 of the original hypotenuse. So this is what we're going to try and do. If we treat it as a triangle, we are looking for the point that is 3/4 of the length of the hypotenuse, or whatever the ratio happens to be in that particular case. So for us, questions you would ask: how do I find 3/4 of the horizontal distance? So that would be horizontal distance. And again, quarters because it's ratio of 3:1. So it'll be 3/4 versus 1/4. Horizontal distance from -2 to 4 is 6 units. 6 units times 3/4, we want 3/4 of that 6 units, is 4.5. So we're going to measure 4.5 from -2, 1 to 4, 3. So we're going to the right. So it'll be 1, 2, 3, 4.5. So this is going to be my new x coordinate, which looks like it's 2.5. So another way to think of it would have been -2 plus 4.5 because we're moving to the right, and that would have been 2.5. So you can do this mathematically or you can count boxes, it doesn't really matter. Vertically, we've got 1 to 3 is 2 units. So 2 times 3/4 is 1.5. So we're going to be counting up 1.5. So going up 1.5. So this will be my new y coordinate. So if I can keep my hand steady enough to draw this across and up, this is going to be my point that I'm looking for. So y coordinate of 2.5 as well. And mathematically, that would have been 1 plus 1.5 is 2.5. So my coordinate is 2.5, 2.5. So you can see visually, like that's where the coordinate would have ended up. So the point itself is a 2.5, 2.5. We did parallel line vertically and horizontally. They both have right angles, so they're similar by side angle side. So everything about this set tells me that the hypotenuse is going to be 3/4 of the full hypotenuse, which is that point we're looking for. All right, in this example, we've got 2 points, C and D, and partitioning the segment in a ratio of 2:1. First thing I would do is just get a visual. You can sketch one, you can do an actual one, it doesn't matter. I like putting it on a graph and saying, okay, what am I looking for here? We're going from C to D, ratio of 2:1. So that would be 2/3 versus 1/3, which means that we're going to be closer to D when we're done. So I'm looking for a point in that circle area somewhere. So let's go look at vertical and horizontal distance. Vertical distance is 3 units. This is nice, it's divisible by 3. So 2/3 of 3 units is 2. So that means we're going to count up 2 units. So my new y coordinate is going to be 0. Now you can tell the point that partitions the segment has to be on the segment itself. So that means that this must be my coordinate, but let's just double check it with the x value just to be sure. So -3 to 6 is 9 units. 2/3 of 9 is 6. Going from C to D, we're counting over 6 units. So 1, 2, 3, 4, 5, 6. And there we go, confirmed. So that will be a coordinate of 3, 0. And this is point P. Okay, in this one, we got a race, start to finish, and the organizers of the race want to put 2 water stations during the race. So longer races, you'll usually get water stations along the way, just usually tables with cups of water where people can rehydrate and then keep going. And they want them to be equally spaced from each other, the start and the finish line. So that means that, quick sketch, we have start, we have finish. There's going to be 2 water stations and they are all equally spaced from each other. So we're going to divide this segment up into 3 equal pieces. And then we need the coordinates of both water stations. Sometimes it just asks you for the first one, sometimes for the second one. In this case, it's asking for both. Just keep an eye out for that. All right, so same process as before. Horizontal distance, we're going from -2 to 4, which is 6 units. And vertical distance is 5 to 4 is 9 units. Dividing it into 3 equal pieces, so this is a nice easy one again. Both are divisible by 3. So 9 divided by 3 is 3 units. So every 3 units, 1, 2, 3, 1, 2, 3, is going to be a division. So if we go horizontally across, basically these are going to be my 2 water stations. We'll check the x value just to make sure. 6 divided by 3 is 2. Every 2 units, 1, 2. And yeah, works out perfectly. So the first water station, so water station 1 and water station 2, that looks like 2. Okay, so water station 1 is at a coordinate of 2, 2. And water station 2 is at a coordinate of 0, -1. That's it. Done. All right, your turn. You've got point P again placed on the line segment AB, so from A to B, ratio of 3 to 2. Pause the video at this point, take a shot at it, then come back and see how you did. All right. For this one, I'm just going to do a rough sketch. So as opposed to pulling out like an actual like grid and coordinate plane, just going to do a rough sketch to see what am I expecting here. So I should do light coordinate plane, doesn't have to be perfect. A is at 4, -6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Like I'm just looking for like a rough placement of where this thing belongs. And B is at -6, 2, 1, 2, 3, 4, 5, 6, 1, 2. So here's our segment. Ratio of 3 to 2 from A to B. So that means there's going to be more of the segment closer, like on the side of A. So if we imagine like halfway is here, it's going to be somewhere in this ballpark, a little over halfway, because it's going to be 3/5 versus 2/5. All right, so let's talk about horizontal distance. From 4 to -6 is 10 units, and 2 to -6 is 8 units. So 1 is divisible by 5, 1 is not. So this is where we start seeing a little bit more kind of trickiness come into it. Horizontal distance, let's do the easy one. So 10, and we want 3/5 of that distance. That's going to be 6. So I'm going to count 6 units from A to B. So that means I'm going from 4 back into the negative, so I'm subtracting 6 from it, and -2 is going to be my new x coordinate. So if I have an answer down here, -2 is my x coordinate. For the y coordinate, 8 times 3/5 is going to be, what's that, 4.8. Now we're going from -6 to 4.8, so it's going to be -6. It's going up, so plus 4.8. That's -1.2. Done. So -2, -1.2. Like, yeah, we were pretty bang on, even with that rough sketch. All right, this one, pictures given to you, so you have a couple, you have more options available to you. Ratio of 3 to 2 again. And you got -4, 2 and 7, 1. Pause the video, take a shot at it. All right, vertical 3, horizontal 11. So this is why this is a little bit more challenging, because neither of them are divisible by 5. So we've got 3 times 3/5. So that is going to be 1.8 from A to B. So we're going down 1.8. So it's going to be 2 minus 1.8, which is 0.2. So that's my y coordinate. And going across, we've got 11 times 3/5, which is 6.6. So we're going from -4 plus 6.6, so that's going to be 2.2. So 2.2, 0.2, that's 2, sorry, so it would be like just like right about there. Perfect. So this is one where like doing it graphically may help, but you'd be trying to guess what the approximate coordinate was. Doing it mathematically, you're going to get that actual answer. And usually we're going to look for accuracy here. So round to the nearest hundredth. There was no need to go into hundredths, but if we did, there would be zeros on the end. All right, so that takes us to the end of today. What are the steps to dividing a segment into equal pieces of the ruler? You draw that ray, you get your compass out, you mark an equal number of pieces, depending on how many segments you want to divide your line segment up into. And then you draw parallel lines from the last one to the end point, and you go parallel to that through all your other markings. Finding a coordinate that divides a segment by a given ratio. You're going to divide the horizontal and the vertical distance by the total number of pieces needed, or the fraction of the entire line that you actually need, and then just count boxes or add or subtract to your X and Y coordinates. Like, very simple, very straightforward, just practice it. So for tonight, there is a worksheet I want you to do. And when I say tonight, I mean you've got like a day to do this. Partitioning a line segment by a given ratio. There's 7 questions on it, and enter your answers into the Schoology assignment. And this one is a graded assignment, guys, so make sure that you are taking your time. You get 2 tries at it, but do your work on paper first, make sure that it's accurate, then input your answers. All right, I'll talk to you soon.